The mean value theorem is one actual theorem you have to learn in calculus. There's a lot of rules in calculus, a lot of procedures, but the mean value theorem is an actual theorem. And I want to go through the process, explain what it means, and I think you'll understand it by the end of it. So first of all, the question is asking us to sketch that graph, x squared plus 16 over x squared plus 5 over the interval 1 to 3. So I went to my calculator and I found out at 1 that the value was negative 10. So I'm putting a point at 1, negative 10. And then I went to 3 and I found out that the value at 3 was 3 and 38 over 9. I think it's a decimal. I'm going to leave it as 38 over 9 just so I can do my work exactly. So then I'm going to connect that and the graph looks something like that. And it might not go through the x-axis exactly where I have it, but that's okay. That's just sort of the general shape. So that's A. B says, draw a line segment connecting the endpoints. Alright, there's my line segment. C says, evaluate the slope of the line segment. Alright, so that would be 38 over 9 minus negative 10 over 3 minus 1. If you work that out, you get 64 over 9, or 7.111. Alright, D says, trace your graphics calculator to the point where it appears that the slope of the tangent line is equal to the slope of the line segment. And then it says draw the tangent line. I can show you this in class tomorrow about how you do that on the calculator. At this point, I just sort of want you to look and figure out where the tangent line maybe would have a similar slope. And as I think about points to draw, I think somewhere around in here, if I draw a tangent line, that tangent line slope will be the same as the slope of the blue line, which connects the two endpoints. Now, it says for you to find the derivative at that point. Well, it's something you can do on the calculator. You could figure out what the tangent line is and go from there. But what should happen is that the derivative should be the same as the slope. Because if the derivative at that point is the point I'm looking for, then the derivative and the slope should have the same, should be the same. F says write an explanation. Don't worry about F at this point. Basically, what I want you to realize is that between 1 and 3, if you connect the graph and make a line, that the slope of that line, that there's somewhere between 1 and 3 that has that same slope if I draw the tangent line. Okay, so we're going to connect. This says that we want to find something between 1 and 9 for where the slope of the secant line formed does something. So we're going to go to 1 and put a point, we're going to go to 9 and put a point, and we're going to draw a line connecting it. And it says that we want the slope of the tangent line somewhere between 1 and 9 to be the same. So I'm going to start over here. Well, if I draw a tangent line anywhere from 1 to 4, the tangent line would be negative, so that wouldn't work. So if I went here, well, this tangent line would be positive, but it seems like it would be too steep. So possibly here at 4, if I drew a tangent line, it would work. But the problem is I can't draw a tangent line at 4 because 4 has a sharp point. So, no. There is no place between 1 and 9 where the slopes would be equal. If I drew any tangent line between 1 and 9, no tangent line I draw is going to have the same slope as the slope between 1 and 9. Alright, so here it asks us to draw a graph 1 over x minus 2. Well, there's an asymptote at 2, which I'm not drawing very well. I'll do it in a highlight maybe. There's the asymptote. And then if you can use your calculator to graph it. And it says to do it from 0 to 5. If I plug in a 0, I get negative a half. I'm going to start there at -1/2 and it comes down. And then I'm going to 5. If I plug in 5, I get 1/3, so that's somewhere around 5 1/3, and it kind of goes like this. Alright, and so the question asked me in B, is there a number between 0 and 5 where the value is equal to the slope of the tangent line there? So we connect the points again, wherever they tell me. They told me from 0 to 5, so I connect those points. And I'm looking for anywhere on the purple that if I draw the tangent line, that I'm going to get a tangent line parallel or the same slope as the red. So anyway, there's no place between there that I could draw the tangent line because the slope is always negative. I'm trying to draw a positive slope. And the problem here is that it's discontinuous. On the previous problem, it was not differentiable at that point. On this problem, it's not discontinuous. So there must be something going on about being able to do this. If you have a graph that's continuous and differentiable like the first one, if you connect two endpoints, there should be somewhere between there where the slope of the tangent line and the slope of the secant line are the same. So let's write out what the mean value theorem says. The mean value theorem says that if you have a function that is differentiable and it's also continuous, that there's one number c between a and b at which the derivative at c equals the slope between a and b. So this stands for the derivative at c, the slope of the tangent line. This stands for the slope of the secant line, just the slope between the 2 points. Number 4 says write the intermediate value theorem. I didn't talk about the intermediate value theorem, but sometimes they talk about it. And what the intermediate value theorem says is that if you have an interval a to b and you have a function f of a that's an f of b, that if you pick any number c between a and b, that f of c will fall between f of a and f of b. So basically, if you have any graph that's continuous and here's a and here's b, that there's somewhere between there where f of c would fall between. It's kind of an obvious kind of theorem, but that's sort of, I just wanted to sort of explain it just in case you've ever seen anything like it. Sometimes you might see abbreviations MVT and IVT. So I'm going to do number 1 on the exercises. Number 1 gives us a function and gives us an interval. And what it's asking us to do is to find the value of c that makes the mean value theorem true. So first of all, what we want to do is figure out the y values at 1 and 4, plug in a 1, plug in a 4, and find the slope between those 2 points. So 1/4 minus 1 over 4 minus 1, which is -3/4 over 3. That's a 3, I know it's hard to see. And if you divide that, you get -1/4. Well, you also, so that's the slope between 1 and 4. That's the slope of the tangent line. Well, then you also find the derivative. And I'm going to rewrite it because I think it'll be easier to solve. And what I want to happen is I want the slope of the tangent line to equal -1/4. So I'm going to set the derivative equal to -1/4. I'm going to cross multiply and solve. -1 times 4 is -4. -1 times x squared is -x squared. Divide by negative, you get x is plus or minus 2. And what that tells me is that for x values 2 and -2, the slope of the tangent line would be -1/4. 2 is in the interval, so 2 is my actual answer, because 2 is the place where the slope of the tangent line equals the slope. We'll do one more. Let's do number 10. Y equals e to the x minus x. And they give us an interval of -1 and 1. And on these problems, basically they're already telling us that the mean value theorem works. Alright, so here's what we have for the x's and the y's. So let's find the slope. E minus 1 minus e plus 1 over 1 minus -1. Alright, that's negative e and minus 1. So e minus 1 minus e minus 1, that's all a -2 over 2, which is -1. And I realize I've already messed up because when I plugged in the -1, I forgot the negative, so I'm going to erase that. I'm very sorry. I think maybe I wrote it, but I didn't write it well. So that should be a -1. So let's start again. That would be for the slope, e minus 1 minus e to the -1 plus 1 over 1 minus -1. Alright, so that's e. The negative goes to the 1, so minus e to the -1 minus 2 over 2. And I know that's kind of strange, but if we want to change it to a decimal, we can do that. I'll go ahead and do that because I know that some of you like that better. And I got a decimal point 175. I'm leaving it all in my calculator there to use it. So what I'm going to be doing is I'm going to find the derivative, and I'm going to set that equal to that value. So the derivative would be e to the x minus 1, and I'm going to set that equal to 0.175 using that whole value I got in the calculator. Now I'm going to go ahead and solve this just the way that you normally would, like you would add 1 on both sides. And then to actually solve it algebraically, you're going to take the natural log on both sides. And when you do natural log of e to the x, that's just x. So when I do natural log of that answer, you get 0.161. And so at this value, the slope is going to equal the slope that I got here. So you start by finding the slope of the secant line. You find the derivative, set it equal to the slope of the secant line, and then solve for x. I wanted to do this one so you could see this process of how to solve right there. So now what I want you to do is to go back and do some of these problems. I won't make you do all of them. I want you to do 2 through 6, and then I also want you to do 11, 12, and 13. And 13 is over on the left side. So do those. Think of them as try problems if you want to. And then also don't forget to finish the little matching worksheet we started in class today.